Okay, question 7. Samuel owns a printing machine. The printing machine is depreciated using the flat rate depreciation. So that becomes important, so I know which formulas. And the value of the machine after n years can be modelled by the recurrence relation. So they've given me a recurrence relation, which means they've got the VO and the n+1 rule. By what amount in dollars does the value decrease each year? So that's pretty easy. We can see that it's this is a model for years. So every year it's going down 15,000. Showing recursive calculation. So you've got to be careful. I actually want you to show determine the value of the machine after 2 years. So you need to show that the formula. So you need to show V1 equals VO, the one before, 120,000 minus 15,000 equals 105,000, and then you have to show that V2 equals 105,000 minus the 15,000 again, which equals 90,000. Okay, so you need to show that exact working out to get the mark. Okay, so the next question is, what is the annual flat rate percentage of depreciation? So when they say annual flat rate, this is obviously per annum, we often call it, and we often see it in our formulas as little r. So I'm going to go and get the flat rate formula off my summary sheet. Okay, so here I can see you found the flat rate formulas, and I want the little r. So I can see there's little r in that formula there. So D equals little r over 100 times VO. Now D is the amount it depreciates per period, so yearly for this one. So I can pop in the 15,000. I know it drops down by that. R is what I want to know, and I know it originally began, the VO was 120,000. So at this point you can just pop solve into your calculator, comma R, and you will get the rate of depreciation to be 12.5%. Okay, in question D, the value of machine after n years, Vn, could also be determined by using the rule of Vn equals A plus Bn. So write the rule for Vn. So this is what we call the nth term formula. So this is when they write Vn like that. You want the nth rule, or you want the nth rule here. So if we go over to our formula sheet, this formula here in the middle of the summary sheet is always the nth rule formula. So you can see if I wrote out the basic one, so Vn equals VO minus n times D. So we know what D is. D equals 15,000. So in this, when they wrote it out like that, that's fine. This A is our VO, and that B value is the D. Okay, so if I write the formula out the way they want it, so Vn equals AO, which is, A, the initial VO, minus, and because it says plus B, but that's okay, we're going to say it's minus B, because that's what B equals, minus 15,000 times n. Okay, so there we go, we've created the nth rule. Okay, so question 8, Samuel has a reducing balance loan. So really important that we know which one this is. So this is a loan, and we've got an amortization table for this loan. Okay, interest is calculated monthly. So we got given a little bit of we know PPY is 12, and he makes monthly payments of 1,600. So if you think about it, this is a loan that he's paying back. So the payments would be going back to the bank. So in terms of finance solver, they will be negative. And it says the interest charge is 3.6 per annum. So they told me and it says calculate the principal reduction associated with the payment number 3. So they want the principal reduction here is the question. Now, when you have a loan, your payment, you need to minus the interest from your payment, and then that would equal the principal reduction. So if we were to go and do this one, we're just going to say the 1600 minus 1600 minus the 956.15 is going to equal the principal reduction. So it's going to be 643.85. Okay. Calculate the balance of the loan after payment number 4 is made. So this second question here, payment number 4, the balance. So we're looking for this spot here. Now, this spot here is generally found by doing, this one is always the balance before minus the principal reduction. So we need to go find out those things. So we need to calculate probably first the interest here and the amount so that we can get the principal reduction for it. So let's go calculate this interest. So I'll copy it in purple. So first of all, so we're going to calculate the interest amount. Now the way we calculate the interest amount is always we do the rate over PPY over 100 times the balance before. So let's have a look. We know the annual interest rate was 3.6. We know it's monthly over 100. Now the balance before for here is this one here. So it's 318,074.23. So we'll get the interest amount, okay, which I get to be 954.22. So I've got into this one would be 954.22, and that looks good because the interest is reducing and it looks reasonable. All right, so we need to get this principal reduction, this one in here. So the principal reduction is equal to the payment minus the interest. So it would be the 1600 minus that 954.22. So we're going to end up with principal reduction, which is 645.78. So now I know the 645.78. I can finally answer the question where I know the balance, we're up here. The balance is equal to the balance before minus the principal reduction. So it will be the balance before, so 318,074.23 minus that principal reduction, 645.78. So it equals 317,428.45, and that's your final answer for that one. Okay, looking at the next question, it says write down a recurrence relation in terms of SO, SN plus 1 and SN can be used the month-to-month balance of the loan. So we might want to go and look at our reference sheet, and we want a recurrence relation for a reducing balance loan. So let's go find that. Okay, so we can see we've gone to reducing balance loan, and I'm in the recurrence relation formula, so I need to write this out. Just be careful, they want you to use S's instead of V. So for a recurrence relation, we have to write SO. So the beginning of this loan, I can see up on the amortization table was 320,000. So I'll pipe that in. And then the next part of the formula is that you'd write SN plus 1 equals, now this, we've got R times, now we're still just using SN minus D. Now D are the payments. If you have a look, sorry, I probably deleted it over here, but D says payments. So we do know the payments are 1,600. So we'll say minus 1,600. But we also need to work out this R value. And you can see you've got a formula right here for the R. So if I just work it out over here, R would be 1 plus the rate per annum, which is 3.6 over 12 over 100. So if you pop that into your calculator, you'll end up with 1.003. So you can write your final formula as Sn plus 1 equals 1.003 times Sn minus 1,600. So what they're looking for is this and this to be written out as a recurrence relation. Okay, Sam opens a savings account. So let's be careful, we're into a savings account now, and the balance of the savings account in dollars after n months, so this is a monthly formula, is opened. The month to month can be determined using this recurrence relation. Write down the value of B4 after the balancing. So for this one, you can simply just do it in your calculator where you just type in your 5,000, press enter, and then you do the answer times 1.003, and that will give you, that will essentially gives you B1, and they want you to keep going to B2. You just keep pressing enter, B3 and B4, and you'll get your answer. Okay, so I just showed you what I did on the calculator there, and I got the B4 to be, because this was B0, 1, 2, 3, 4, to be 5060.27. Alright, next thing it says calculate the interest rate percentage, the monthly interest rate percentage. Now, because this is a monthly, it wants the monthly interest rate, and this is a month-to-month formula, the interest rate is this bit, well, the way they found the rate is in there, okay? So it's actually that, all you have to do is actually times that 0.003, the extra part, you just times it by 100, which would mean you end up with 0.3% is the month-to-month rate. Okay, so you would have found that 1.003 by doing the per annum rate divided by 12 over 100, and it would have been 1 plus or whatever. So they just want the monthly rate, so which is already there, so we can do that. After 1 year, the balance of Samuel's savings account to the nearest dollar is this. So this is 1 year, which actually means N is 12 months. If Samuel has deposited an additional $50 at the end of each month immediately after interest was added, how much extra money would be in the savings account 1 year after 1 year? So you want to know, probably you want the final value at n equals 12. So we could probably use finance solver here, where we go n equals 12, the interest rate. We actually don't know the per annum interest rate. This is the monthly, but we could do 0.3 times 12 in there, and that'll be all right. PV, he initially invested 5,000. I'm reading that off the VO. He's making extra payments, which is also giving to the bank, negative 50, and the final value is actually what I want to know, and PPY is 12. Alright, so let's go do that on the calculator. Okay, so we get a final value of 5793.00 if you round it. So that's what he would have got if he'd put the 50, and then they said after 1 year it was that. So if you do the 5793 minus the 5183, you end up with 610 as the extra around how much extra would he have gotten? He would have got it 610 extra. Okay, so Sam now invests his 500,000 in an annuity. So we're most likely heading into finance solver now. So PV will be a negative for an annuity. He receives regular monthly payments. So that is PPY is 12. And we also know because he's receiving payments will be positive on finance solver. Okay, and here he goes. Here's a recurrence relation of the investment. So just take note, when you have a recurrence relation of the investment, that is actually, when it has a negative thing there, that is the payments that you're receiving. So that actually in finance solver, that's a positive. So calculate the annuity after 2 months if K is 1.0024. So because this is a monthly model, you could just simply do it in the calculator where you go 500,000, press enter, and then you do the times because K is 1.0024, times that 500,000 minus 2, and then you just do that 2,000, just do that twice. Okay, so I've just done that in the calculator. So once you type that 5,000, it'll say answer and then you do that. So we said after 2 months, the total will be the 498,398.08. Okay, calculate the annual compound interest rate percentage for the annuity if K equals that. Now, because that's monthly, so this is like before, it's the interest rate is the growth bit, which is the bit that comes after 1. So if you got 0.0024 and then you times 100, that would give the monthly rate. But they want the annual, so we then have to times that by 12. So I get 2.88%. Okay, what is the value of K? For what value of K would the investment act as a perpetuity? So what you have to know is the perpetuity is that when you have that, your payments need to equal the interest amount increase. Okay, so we know that this is the payment is 2,000, so we need that when we times it by the monthly rate, by the 500,000, we need it to equal the 2,000. So what you're really doing is if you do this, so we just call this the monthly rate and have 2,000 equals. So, and then if you do that as a solve, you find that M equals 0.004. So that's the increase part. So when they're talking about K, they actually want it'll be 1 plus the growth, sorry. So we'd want 1.04 to grow. So K equals 1.04. Okay, so we're looking at the last question now, which we'd expect to be doing a bit of work. So just have that in your mind. So Sam's looking at a new reducing balance loan. So just make sure with an interest rate of 4.1% compounding monthly. So you just might want to write a few things. That's I, PPY is 12. Okay, the balance after 4 years of monthly payments is this. So they've actually given you N times 12. So when N is 4 times 12, they've given you a final value there, which would be this guy. And then they said the balance after 7 years, so it'd be 7 times 12. They also gave a final value of that one. Sam will continue to make the same monthly payments. To ensure the loan is fully paid to the nearest cent required, the final repayment will be lower. The first 7 years, Samuel made 84 monthly repayments. From this point, how many monthly repayments will Samuel make to fully repay the loan? Alright, so what we want to know is they want to know how much more after the 7 years he will have to pay the loan. So let's think this, if we think about, okay, this is after those first 7 years. Okay, so if we know N will be the question, because that's what they want to know, how many more monthly payments. The interest rate is staying the same, 4.1, sorry. Now, PV, we don't know, but that's not the question. So we need to, somehow we'll have to work this one out. And the payments, he will continue to make the same monthly payments. So I need to know this as well. And after the 7 years, he wants to, we want to see how long it'll take to zero off. And they're saying that the final payment will be lower. So what point, how many more monthly payments will he make? And then we've got PPY, we know that is 12. So we've got a few things missing. So what we're going to do is, for our missing things, we're going to use these two scenarios. And I'm going to pretend that I'm going to go between the 4th and the 7th year. So, and I'm going to pretend that the 4th year is like the beginning and the 7th year is like the end. So really, we have 3 years in there. Okay, so N would be 3 times 12. Interest rate will be 4.1. Now, the PV, I'm going to pretend the 4th year is the beginning. So this is a loan, so it would be a positive amount. So I'm putting that 4th year total into my PV. Now, payment, this is where I might be able to find out a payment. So here's where I'm going to find one missing piece of data. And PP, and then we'd have FV. And what I'm going to do is say that's at the end of the 7 years. Now he's still owing, so it's a negative 875.15, and the PPY is 12. Okay, so let's go find, this way we can find out what his payments are. Okay, so I get my payments to be negative 2,400.00. So now I know that his payments are that in this scenario. And actually, we do know we're going to pretend the next 7 years, so we need to know how many more. So this means at this 7 years, this is the PV will be the total at 7 years owing. So it's going to be 280,875.15. And it's positive because we're pretending it's a loan, so you're getting it. So this is the final value at the 7 years, because we're going to start again and see how long. So now we've got everything, we can now go find out how many more number of years it will be, or months it will be. Okay, so we do that and I get 149.7. Okay, now how many more monthly payments to pay the fully written loan? So 149 he hasn't quite paid. The 150th will still be a repayment. It will be shorter, but they just wrote how many more monthly payments. So 150 more monthly payments. Even though the last one will be adjusted, it's still a payment. So 150 more monthly payments. That's how we found out. Okay, and that's the answer.